Good morning, everyone. My name is Junliang Zou. I'm from Teagasc Forestry Department and also from the Climate Center. Today, I'm going to give an overview of the existing knowledge on forestry carbon accounting in Ireland. Carbon sequestration is the process of capturing atmospheric carbon dioxide, and it's very important in mitigating climate change by absorbing carbon dioxide, a major greenhouse gas from the atmosphere. Forests play a very significant role in mitigating climate change by continuously absorbing carbon dioxide and releasing carbon dioxide. There are 5 pools in forests. There are above ground biomass, below ground biomass, litter, dead wood, and soil carbon. Trees absorb CO2 from the atmosphere during photosynthesis, and the fixed carbon is allocated in these 5 pools and stored in these 5 pools. Carbon is released back into the atmosphere through decomposition and respiration. The final output of the carbon in the forest is the sum of the carbon stock changes in these pools. There are 4 major sequestration pathways associated with forest. There are carbon sequestration in growing forest biomass and soil pools, carbon storage in harvest wood products, and the substitution of fossil fuel with wood energy and substitution of energy-intensive materials. Ireland has committed to reduce greenhouse gas emissions and enhancing carbon sequestration through a range of measures within agricultural, land use change, and forestry sectors. Ireland's forestry strategy targets a major expansion of climate-resilient forest to 18% of total land area. However, the path of this will depend on the level of engagement by landowners and sketch holders in demand-led afforestation schemes. The Climate Action Plan identified key measures in meeting these objectives, including afforestation, sustainable management, increased use of long-lived harvest wood products. Forest efforts align with EU ambitions and international agreements such as Paris Agreement to limit global warming to well below 2 degrees Celsius above pre-industry levels. Nearly half of a tree's dry biomass is carbon. Most of that carbon is retained when harvest wood becomes harvest wood products such as furniture and flooring. Reusing food further prolongs carbon sequestration. When done correctly, harvesting trees from forests to make wood products also creates conditions for the removal of additional carbon dioxide from the atmosphere. According to the National Inventory Report, the average carbon sequestration from forest land was about 2.45 million tons CO2 equivalent per year. The sequestration from harvest wood was about 0.83 million tons CO2 equivalent per year. The Teagasc analysis to 2030 describes options to increasing the climate change mitigation from forests up to 2030. Among the 4 options, there are extended rotations, agroforestry creation, afforestation, and prevent deforestation. Among these 4 options, adjusted rotations contribute the largest carbon sequestration, which is around 0.9 million tons CO2 equivalent per year up to 2030. Increasing afforestation to 8,000 hectares by 2030 and maintain this rate by 2050. The carbon sink would be 1.3 million tons CO2, higher compared to the afforestation rate of 2,000 hectares per annum. When compared to non-afforestation, the carbon sink would be 2.1 million tons higher. The cumulative extra sequestration from 2024 to 2050 would be over 10 million tons CO2. Historically, Ireland has experienced various phases of afforestation, with notable efforts from mid-20th century to the present. The forest cover has risen from about 1.5% in 1920 to over 11.6% in 2022. Planting patterns indicate that public planting predominantly occurred until mid-1990s, which are mostly on peat soils, with private planting increasing from early 1990s. However, there are still some challenges. As indicated in forestry strategy, we have a planting target of 18% of forest cover. The second challenge is to optimize the resources from over 23,000 forest owners with an average size of 8.6 hectares. A key challenge is to address recent low afforestation rates. Now, afforestation on peat soils are not allowed, as there's in terms of carbon sequestration, it is a risk. Recent research in 2021 has updated an emission factor of 1.68 tons carbon per hectare per year, which is 3 times of the previous used emission factor of 0.95 tons carbon per hectare per year. By using the updated emission factor, the carbon sequestration from the forest land is estimated to be 1.8 million tons CO2 equivalent. That means the estimation from the new updated emission factor has caused the estimation from forest land sequestration reduced by about 50%. Ireland employs several methods to estimate carbon stocks from forest. They include remote sensing, ground-based monitoring, inventory modeling. Remote sensing utilizes advanced satellite and aerial imaging techniques to analyze forest cover, biomass, and changes over time to quantify carbon stocks. My colleague Stuart Green will give more details on his talk. And ground-based monitoring involves field surveys and sample plots to measure tree size, growth, and other factors to estimate carbon storage in trees, plants, and soils. The previous talks from Julian, Mr. Saunders, and Rachel has already provided plenty of information on this method. Inventory modeling employs sophisticated computer models, integrate remote sensing field data and other inputs to project forest carbon dynamics at national and regional scales. Here I'm showing some applications of the recent technology like edit covariance on forestry carbon accounting. This picture shows the agroforestry demonstration plots, which has recently applied edflux tower, which are maintained by Teagasc. This site is just beside the Johnston Castle. And this is another site located in Irish Midlands from County. It's a Teagasc forest where I have worked many years ago, and it's maintained by UCD. Teagasc, in conjunction with staff and Forester Research Services Ltd, has developed a user-friendly tool. It's called Online Forest Carbon Tool. This tool is aimed to raise awareness about afforestation's role in climate mitigation and to provide up-to-date information on carbon sequestration for various afforestation methods, as well as to allow users to compare the effectiveness. Our aim is to update this tool when more science-based information becomes available. Forest carbon sequestration can be influenced by several factors, such as forest type, soil type, site conditions, productivity, and forest management, and so on. Here I'm showing 4 different types of forest under the new afforestation programs as examples. There are forest type 12, mixed high forests, which are fast-growing, mainly conifer species, with 20% mixture of broadleaf species providing high carbon sequestration rates. Forest type 1 native woodlands provide biodiversity benefits and moderate carbon sequestration. Forest type 7 are the broadleaf, fast-growing broadleaves, including birch, alder, and sycamore, as well as forest type 8 agroforestry, which combines agriculture and trees on same land with many co-benefits. There are two normalized carbon sequestration values shown in this slide. The annual average carbon sequestration rates over time, and the cap value, which is a measure of the maximum carbon sequestration potential. Generally, forests with a higher carbon sequestration rates will reach the cap sooner than forests with a lower carbon sequestration rates. For example, forest type 7 other broadleaves reaches the cap. It takes longer to reach the cap because forest type 7 has a lower carbon sequestration rates compared to forest type 12. Higher timber yield is achieved on better site conditions, which largely determine the productivity. According to the Forest Carbon tool, Teagasc spruce with a higher yield class, which has a higher carbon sequestration rates compared to the lower yield class 14, which only have like 6.6 tons CO2 equivalent per year. There's a difference of around 2 tons CO2 equivalent per year, per hectare per year. This figure shows that compared to unmanaged forest, managed forest could have triple benefits. One is the carbon sequestration on site, and also the carbon storage in harvest wood products, as well as the substitution of fossil fuels and also bioenergy. Specifically from this graph, if you take a look at the 100 years, the black dashed line indicates the carbon sequestration over time from the unmanaged forest. Well, the green lines indicate the carbon sequestration from the forest for the managed forest. Well, the continued inflow of carbon from the harvest wood and also the substitution of for the energy-intensive materials and also the bioenergy, we can see that the managed forest have a nearly double of the carbon stocks for managed forest compared to the unmanaged forest at 100 years. With the time progress, the carbon storage is even higher compared to unmanaged forest. The key message for my talk is that forest creation, appropriate management, and use of long-lived harvest wood products can significantly contribute to island's carbon emission targets. High rates of afforestation required to meet climate neutrality targets 2050. There's a strong need for science-based knowledge on forest carbon dynamics. We need to work collaboratively to address identified knowledge gaps, such as forest management practices like continuous covered forest, extended rotations on carbon sequestration rates, the impact of natural disturbances, such as the uncertainty of future climate change on carbon sequestration rates, and also there's a need to refine emissions from organic soils, as well as species-specific dynamics on carbon sequestration, especially the broadleaf species. I would like to take this opportunity to thank all the collaborators for their valuable contribution to this work. Thank you for your attention.